now we are going to start with counting significant figures. So let's say we have, I'm going to give you example and then define rules. Okay. So we have this measurement 3, 4, 5, 6. Now in this digit there is no zeros in it, right? So that means we can call this one has 4 significant figures. Why? There is a rule for that. We can say non-zero integers or numbers. We can say non-zero numbers always count as significant figures. That's the first rule. If there is no non-zero, you count all of them. Okay? Now, there are 3 classes of zeros. What that means? Let's say the number contains zeros. Alright? And there are 3 types. I'm going to tell you. The first one is called leading zeros. I'm saying leading zero. Leading zero means what? The number has, let's say, 0.078. So this number is called leading zeros. Okay? For that there is a rule. If it is leading zeros, the number contains leading zeros, okay, we do not count. So we do not count this zero as a sig fig. We can say it has 2 sig fig. Alright, so I'm going to write that rule. For leading zeros, we can say leading zeros do not count as sig fig, significant figures. Now that's just one class. We need to consider 2 more classes of zeros. Alright, so what are those? So let's talk about that. Next one is called capitative zero or embedded zeros. So the second class is called capitative zero, or we can say embedded zero. Let me rewrite this one. Embedded. What that means? That zero is between those numbers. So for example, let's say 16.09. This zero is between these 2 numbers, right? So that's called capitative zero. In that case, we count all numbers. So that means, let's say, I'm going to rewrite again because we cannot. 16.09. This is a point. In that case, we can say this number has 4 sig figs. What rule we follow? So I'm going to write that rule now. Capitative zeros always count as significant figures. So that's another class of zero. Now we talk about leading zeros, capitative zeros. Now we'll talk about trailing zeros. So that's trailing zero. So trailing means what? Towards the end, right? So there are two kinds, 9.300, or we can have 150. There are two types, okay? Now you can see these are trailing zero, this is trailing zero. Now these zeros, there is a decimal point, and this zero, there is no decimal point, okay? So for this number has 4 sig fig, and this number has 2 sig fig. So for that, we need to follow two kinds of rule in the trailing zeros. What are those? So if it is decimal point and the number is more than 1, then we can count all number as a sig fig, right? So, and then there is a no decimal point, then we cannot count, right? So I'm going to write in here. Okay, we can write trailing zeros are significant if the number contains decimal point. Again, I'm going to give you an example. 101.1 and 101. Okay, hold on. That's not a trailing zero. Let me give you one more. 100.0 and 100. Alright? Now when you see here, both are examples of trailing zero. One has a decimal point, one does not. So that means when you count significant figures, we can say, following this rule, the number contains decimal point that we count. So we can have 1, 2, 3, 4. So this one has 4 sig fig. This number has 4 sig fig. And this number has how many sig fig? Just 1 sig fig, because it does not have decimal point. So that's where we follow counting significant figures. Okay? Now, there is one more rule. Exact numbers have infinite number of sig fig. For example, 1 inch equals 2.54 centimeters. So that's exact numbers. Alright, now exponential notations, how we can write significant figures and exponential notation. So let me go to next slide, and let's say if we have 300 point written as 3.00 times 10 raised to 12. That means when you write in scientific notation, we still consider this number and we can say it contains how many? 3 significant figures. Got that? Right? So that means these number, whatever the significant figures we can count, that's the significant figures in exponential notation. Alright? So now we'll practice on counting significant numbers. Questions so far? Yes?
So